Okay, welcome to WASA Distance Education. This is MBF3C, Grade 11 College Prep Math. I'm Pete, and I'm here. So, yeah, so welcome to Class 2 of Week 4. So, what we're going to do this week, we're going to wrap up the last of Unit 2. We should get to Lesson 10 by the end of the week. So yesterday we took a look at lesson 9, so that was loans. We looked at different ways that we can calculate the parameters of a loan. If you know the present value of the loan, the interest rate, and the terms of the loan, how many compounding periods, what for how long it is, then you can go ahead and calculate the regular payment that you would have to make to pay off that loan in the stated amount of time. Okay. Now, if you know what the regular payment is, there's a couple of things you can do with that. One of them is you could use the other version of the formula to calculate the present value of the loan. That is, what is the cash value of that loan right now, right at the beginning of the loan, right? Because if someone, if someone's selling you something and they state a certain price for it, right? Usually that's the present value of the loan, right? And then the cost you pay for the loan is the interest rate. Okay, so you're going to pay a certain amount of interest. The other thing we looked at yesterday was how to calculate what was called the total cost of the loan, or the total amount of the loan. And that is a very simple calculation, but it's important to recognize when you're being asked for that. The total cost of the loan, not the equivalent price, because that's the present value, but rather the total cost of the loan is the number of regular payments times the number of compounding periods, or the number of the length of the loan by the number of compounding periods in years by the number of compounding periods per year. However you want to do it, it's your N. Okay, so it's your regular payment times N. And that gives you the total that you're going to pay out over the life of that loan, which is going to be more than the PV, because the PV, the present value, is an investment, right? Basically, let's say someone wants to buy a laptop, or sell you a laptop, right? So what they let you do is they let you pay, right? They basically loan you that money, okay? And then they let you pay it off. Right, so that's the loan is the interest that you pay. So when you get the total cost of a loan, the total amount, that's the A, which is your PV plus I. So if you know the PV, then you can work out the interest that you pay. Okay, so that's the whole thing about loans. We'll take a look at. We'll finish up this Anna question, the support questions on page 23. And then we'll continue on, because the opposite of a loan, which a lot of people will encounter in their life, we all borrow money at some point, usually for things that are just a little too big to, that we need right away. They're a little too big to save up for. And then at the other side of things, very often we get a regular income, okay, through some sort of financial arrangement like an RRSP. And usually this is part of retirement, right? Our retirement plan, you move in with your kids, that's great, but usually the government has some money in form of Canada Pension Plan. Some company plans or some companies offer pension plans. It's less common nowadays. And then individuals can put a little bit of money aside on a regular basis into an RRSP, and then when it's time to retire, you can get that money out as a regular payment in a variety of ways. Okay, and so we'll look at that in the second half of this. But let's finish off this question on page 23 that we started looking at on yesterday. So it's Anna. So it says Anna is planning to buy a stereo. Oh yes, I remember that, the stereo. Okay, she can afford to deposit $50 bi-weekly, so we figured out that that's our regular payment for the next 4 years. Okay, if the interest rate is 7.6% compounded bi-weekly, which is, we had to look that up, and as it turns out, it wasn't even on our chart. That's 26 per year. It's every other week. what is the maximum amount that Anna can afford to pay for the stereo? So what we're trying to find out is what is her maximum PV, right? Because if she knows that there's a, say the Northern is selling stereos, okay, so she knows that they sell stereos for certain amounts at the Northern, and she knows that if she wants to put it on some sort of payment plan, she can get those terms 7.6% for 4 years. But she needs to figure out how much she can afford, what kind of stereo she can afford before she goes there. Okay, so that's what we're looking at here. All right, I'm just gonna grab that page out of my notebook. So I'll click here, and I'm gonna make a new page just so that we can start fresh here. Okay, so you can still be watching. This is page 23. So this is this is page. Okay, I'm having my problems here. Yeah, it's still doing it. All right, let's try it again. All right, no. There we go. No, still not. I don't know. All right. No, still trying to make me erase stuff. I don't know what's going on. Okay, there's that. There's that. So it thinks that I have the eraser out. I'm not really sure why. Sorry, just having a little technical difficulty here. Okay, now I got it. Nope. It's still doing the eraser thing. I don't know. Just having a little, we'll sort this out. I'm sure that there's some. Oh, look at that. I got it. I don't know exactly what I did, but I got it. I wiggled things. I jiggled things. So this is page 23. And so this is a support question, SQ support question number 2. Okay. And so we decided, so what we don't know is the PV. That's what we want to find out. We know that she can afford to pay $50 bi-weekly. Okay. And our interest rate is going to be 0.76 divided by, now it's bi-weekly, so that's 26 payments. And I'm just going to make that 0. Okay, well, it's an ugly looking 0, but it looked a little too much like a 6 earlier on. Okay, and then our N, so it's going to be, well, bi-weekly is 26 per year, and that's 4 years. So it's going to be pretty close to 100, eh? Because it should be, maybe, is it 104? Yeah, it's 104. Okay. All right, so that's 104 payments at $50 each. All right, well, I think that that's everything, and now we just have to use the form that for the present values, where we actually work out what possible PV. Now this is going to be, let's just make it clear here, this is the max value. Okay, so this doesn't mean that she's bought a stereo for that amount. That's just the upper limit of how much she can spend, and only be paying $50 bi-weekly. Okay, so if she sees a stereo that costs more than that, then she's going to have to do something. She'll probably have to maybe see if she could pay $51 or $52, or maybe negotiate the price down a bit. Okay, something like that. Okay, but she could buy a stereo that's half the cost of the PV, right? And then she doesn't have to put quite as much away. All right, so the formula we're going to use is PV equals R, the regular payment, times 1 minus 1 plus I to the power negative n. Watch that negative n there, over I. Okay, let's see if we can. So it's $50. And again, that's just a test to see what the maximum is. And that's, you know, when you're trying to solve, solve what-if questions for finance, for money amounts, that's what you do. You use numbers. You say, well, what's the worst it could be, right? Right. and then you go from there, right? 0.76 divided by 26. Okay, I think that's everything. I think we got it. I'm going to extend the page here, give me a little more room. And I'm just going to move over just to the left a little bit. So now I have to grab my calculator and work out all this. And hopefully I'll not make any mistakes here. This is, these are tricky. And one of the things is you want to have an idea as you're doing these what you're expecting, right? So it's kind of hard to know what we're expecting here. But I don't know, is it going to be like a couple $1,000 maybe at most? Kind of hard to say. Okay, so, and then I'm still working this out here. Times 50 times 26. So I multiplied everything on the top by 26 as well. I'll just write what I have here. It's 340, 3554196. Now notice I'm putting down all the digits I have there because I'm not ready to round yet. I want to keep as much as I can. Of course, I'm not actually going to re-enter those. I have them in my calculator, and I'm just going to divide that whole thing by 0.076. So I have 4,478.36, which that looks reasonable to me. So that's how much she could spend, maximum how much she could spend on a stereo. So she goes in Northern, she sees a really nice stereo, it costs $4,450, then she's fine. She knows that she can afford that because she knows she can afford $50 bi-weekly. But if she saw one for $5,000, she can't afford it because it would cost her more than $51 bi-weekly. So that's how having some knowledge will help you, right? You go into the store, you don't suddenly, you don't fall in love with the stereo that costs more than you can afford. Okay. So that's how you do those questions. Let's take a look at some of the other ones. I'll leave you to do the rest of them. I think number 3 looked pretty straightforward. It doesn't look too bad. Question 4 looks like they have a down payment. So what are you going to do about that down payment? How does that change, right? The initial value of the loan. Okay. You gotta work through that. Okay. Now that, by the way, is a sign that something is going right. James is buying a motorcycle and he has a down payment. It looks like 10%, which is a really good down payment. Okay. So just from a financial point of view, it shows that James is probably doing the right thing here, right? The issue is, let's say James wants to buy a motorcycle and he doesn't have any down payment and he's going to make monthly payments. The question you have to ask yourself is, if he couldn't save up for a down payment, then how can he have extra money to make the monthly payments? That's the same question the bank's going to ask. So that's what that down payment's all about. That demonstrates that you've been saving money for a little while. And, if you think your monthly payment is going to be $400 for the motorcycle, if you save $400 a month for 5 or 6 months, then that shows the bank, shows the finance company that you do have that money available, right, to make payments. Okay, so that's why, it's kind of funny. People, they say, why don't they give us a loan? We don't have any money. You need money to make a loan. Really what you need is to demonstrate that you can repay a loan, and that usually means that you have enough money in your budget to build up some savings to make a down payment. Okay, it's the same goes for houses and cars and everything else. Okay. Now, question 5 is just a question. It's just 2 different interest rates, and these are fairly high for today. There was a time when interest rates were quite high like that, but interest rates are in the 4, 5, 6% now. And what they're really showing is that if people pay their bills on time all the time, they never miss payments. They only have one credit card and maybe a car loan or something, then they usually get a lower interest rate than someone that has some financial problems. Maybe they didn't pay a bill, or they were always late or something like that. Okay, and it can save you some money staying in good standing. Even if you can't pay, if you call the company, sometimes they won't necessarily um, put you know put you on their naughty list if you have a good reason, as long as you talk to them. All right, so we're on page 23 now, and we're going to look at RRSP. So I talked about that. RRSP stands for Registered Retirement Savings Plan. Now, I will tell you that there's because things have changed since this course material was written, there are other things that you can get. Tax-free savings account. Okay, for a lot of people, that actually may be a better deal than an RRSP. So it's something that you would really have to talk to the bank about. Of course, they advise you to talk to a financial advisor, but yeah, who's going to do that, right? Um, but just something to look into anyway, a tax-free savings account. For relatively small amounts of money, you can put $50 or $100 in the TFSA every week, every other week. And it may be a little easier to get into than the RRSP. Anyway, RRSP is a more traditional type of investment plan. I have one, and I've had one for a long time. So Registered Retirement Savings Plan. So basically, what you do is you take a portion of your pay and you put it in this special account, and the government doesn't charge you tax on that money when you put it in. Okay, so if your tax rate's 30% or 25%, which is it's a lot of cases it's going to be something like that. So if you put $100 in, then basically the government doesn't charge you tax on that. So you save about $25 or $30, whatever your tax rate is, on that deposit. Okay. And what happens is the money goes into the RSP, it goes into different types of investments, and it makes money, and 20, 30 years later, 40 years later, you start taking the money out. They actually make you start taking the money out when you hit a certain age. You have to convert the RRSP to something else, to a retirement income fund, and there's all sorts of other things that you do. So the government then taxes the money. The idea is that when you're old, when you're retired, you're probably not making as much money as you were when you were young. So there's a bit of a tax savings for you that way. And plus, it gives you regular income when you're old and you don't want to work anymore. Okay. Usually, I think depending on your age, it's either 65 or 67. You can start taking money out. You can actually start taking money out later than that, or leave it a few years. I think 70. There's some upper limit where you have to take the money out, and depending on your circumstance, you may be able to start taking the money out earlier. The problem is that if you take the money out before you retire, before you hit a certain age, then the government basically taxes it, so you don't want that, right? This is something that you put the money in, and you're not going to need it until you retire. Okay, so this is not really a savings in that sense. It's a retirement savings. Okay, so most banks offer RRSPs, and it's pretty easy to set them up. Okay, now the thing about the RRSP is this, right? Where you can, they have this thing called the annuity formula, which may look pretty familiar to you, right? And what you're really trying to do is work out what your regular payment from the retirement plan is going to be. Okay, so the best way to understand this is to look at this. Okay, to look at the example. So this is page 24, and we'll see how this works. So Nick, again, to contribute to his RRSP at age 25. That's where a lot of us started. Okay, but it's depending on our circumstances, right? Some people start a little later. Some people are able to start a little earlier. He made yearly contributions that averaged $2,000. Okay, so if you work that out, that's what is that? If he was paying into it every week, that would be 2,000. Oops, that'd be 2,000 divided by 52. Okay, so that's about $39 a week. Okay, $40 a week. Okay, so that's about it, and that's for someone that's kind of a little bit established. That's not bad. What we tend to try to to do is every time you get a raise, you increase the amount of your contribution, right? So if you're contributing $20 a week, right, and then you get a small raise, maybe you could make it $25 a week, you know. And so by the time you're close to retirement, you're probably contributing quite a bit more. Maybe it's $100 a week. So he begins contributing at age 25. Yearly contributions at average 20,000. His RRSP earned interest at an average rate of 7.5% compounded annually. That's a pretty good rate of return for a relatively safe RRSP. You don't want to make really wild investments. And typically, if you sign up for one of the bank's plans, it's pretty conservative. They don't, they don't invest in really crazy stuff. You don't make as much money that way, but it's a lot safer. You're not going to risk losing all your retirement savings. So it's compounded annually until his 65th birthday to determine the amount in his RRSP on his 65th birthday. So the regular payment, so this is what he's basically doing is working out what we're doing is we're working out what the value is going to be with a regular payment like that. Okay. So $2,000, the interest rate is 0.75. It's compounded annually, so it would be 7.5% divided by 1, which is just 7.5%. And you got to watch it because the number of years of the investment, in this case, he starts at 25. So it's 25 minus 65 when he stops, so for 40 years. Okay. So they plot all those numbers in, and we see that Nick has about $454,000 dollars in his RRSP, $454,513 in his RRSP. Okay, so on his 65th birthday, now he goes to the bank and he says, "Okay, I'm retiring. I'm going to fish, right? I'm going to drive my snowmobile around, and I'm going to play with my grandkids. That's what I'm going to do. I'm not going to work." Right? And so then the bank will sell him something that basically reverses this, right? But it won't be 40 years. They'll say, "Well, Nick, how long do you figure you're going to need this money?" Right? He figures, maybe 20 years. Right? So 65, 75, 85, he figures by 85, someone will take him in. So when he turns 65, they're going to turn this around and he'll buy an annuity where they will be paying him a regular payment every week, which will be quite a bit more than the $50 or $39 he's been putting in. Okay, and that's what he'll do. That'll be his income. Okay, all right. And now here's another example. This shows you, some people you just can't, because of your circumstances, get started contributing to that RRSP. So this is an example where he waits, instead of 25, he's going to wait till he's 40. Okay, but he was able to contribute a bit more money, and that's typical. People who are older who start contributing to an RRSP will, put a bit more money in it because they're making more money, right? When you're young and you're not making a lot of money, pretty much every dollar you make goes to just surviving, right? Food and accommodations, paying for the car, paying for the baby, whatever. But once you get a little older, you get a bit more money. There's a bit more slack in your budget, right? And then you can make a bigger contribution to your savings, your retirement savings. Okay. So in this case, our regular payment was $5,000 annually, same interest rate, but the difference is it was only earning income on that regular payment for 15 years. So it works it out, and you can see that he has $130,500. So it's nothing to sneeze at. I mean, it's a fairly good chunk of money, but it's nowhere near as much as if he starts when he's 25. Okay, so this is just basically the book's way of showing you that the earlier you get started, the better. And with any amount of money, if it's $20 a week, then it's $20 a week. Where do you find that $20 a week? Well, part of it is, using your financial knowledge to maybe make better financial decisions, right? You realize, maybe buying stuff on credit, whatever, may not be the best. And if you stop doing that, you might save money that way. Some financial advisors tell you not to buy a latte. I don't think too many of us are buying lattes. But what they're really saying is, find something that's frivolous, that you really don't need, and see if you can cut back on it. Not even cut it out, just cut back on it. So if somebody stops at Tim Hortons here in Sioux Lookout every day and they spend $3 every day, maybe they could stop twice a week and then take out that $9 that they save and then put that in a retirement fund. Those are the types of decisions that um, having an insight into your finances will help you decide. Maybe you like your Timmy's in the morning, so that wouldn't be something that you would do, and that's fine, right? As long as we have insight into what it's costing us. So here's an example on page 25. Suppose Lucy retires on her 60th birthday. Okay, 60, and some people do that, right? Maybe they worked really hard, maybe they have health problems, and maybe they just, they have other things they want to do. They want to, watch their grandkids. They want to, so let's say Lucy retires on her 60th birthday. The amount of all investments in her RSP is about $750,000. And that can happen, you start really young. If she worked for a company that had a pension way back, because a lot of companies had pensions, years ago, and then when she stops working for them, then that money goes into her RSP. So that's how that comes about. So she decides that $650,000 of it will be invested in an annuity that pays an average rate of 8% compounded monthly for the next 25 years. What monthly pension will she receive? So here's what Lucy does. She turns 60. She says, that's it. I'm done. And then two things happen. One is she takes some of the RSP money, not all of it. She saves $100,000, and she spends $650,000 of it on this annuity. Okay, it's a product that you buy. You go to the bank and you say, I want an annuity. I want to buy it. Cash out my RSP. Right. So again, the government's not going to charge you any taxes on that money until you start getting those checks, and then they'll take some money off of it, right? As if it was a paycheck. Now, what's she going to do with that $100,000? Yeah, who knows, right? Maybe she wants to buy a new house or upgrade her existing house. Maybe she's got some grandkids that are in school. She wants to help them out. Maybe she wants to buy a really nice ATV. Well, I guess that would not be the whole 100,000 with a heated helmet. I don't know. That still wouldn't be the whole 100,000. Yeah, I just found out they're heated helmets. I snowmobiled for years. I didn't know they had heated helmets now. That's kind of cool. Anyway, so whatever, she's got that 100,000. She's just gonna save that. Maybe leave it in the RSP. Whatever she's gonna do with that. It's just a little cash that she didn't want to commit to this pension. She wanted to have some cash on hand. Maybe she wants to travel around the world. So the thing is, we want to know what her regular income is going to be. Now, it's going to pay an average rate of 8%. That's a little high, to be honest, nowadays. But, it's not bad, because over 25 years, it may average out to 8%. So we're going to use the regular payment version of the annuity formula. Okay, so the present value, $650,000. The interest rate is 8%. Compounded monthly, and our N is 25 years times 12 per year. You've seen me, I do that calculation the other way around. I do the number per year times the number of years, but it works out to be the same thing. So this is the version of the formula we're going to use. Remember, we want to find out how much she's going to get on a regular basis, right? So we put all those in the formula, and there you go. So every month, Lucy's going to receive a check for $5,016.81. Now, she will have to pay taxes on that, but if that's her only source of income, right, then really she's probably in a relatively low tax bracket, so she's not going to pay that much tax, probably less than when she was working. Okay. So that's not so bad. So imagine every month she gets $5,000, and maybe it turns out to be $4,000 by the time she pays all her taxes. But that's, a lot of people can live on that, and that's fine. And she gets that for 25 years. Now the question is, what happens after 25 years? Well, let's see. At 25 years, she's 60 now, so 70, 80, she'll be 85. So at 85, Lucy's figuring, she should probably just go and live with one of her grandkids or something like that, or, right? Who knows? Now, Lucy would have to, and it's really hard to know, right? But if you come from people that live for a very long time, you might want to make it 30 years, just in case. All right, here we are. We're on page 26, and so let's take a look at the support questions. Okay, let's try some of these. So Mary is converting her RRSP into an income fund. Okay, so that's a more common type of thing. Again, an income fund doesn't guarantee you quite the same way. Let's see. Okay, okay, so they are guaranteeing a minimum there for that type of fund. Okay, well that works. So Mary is converting her RSP into an income fund. She wishes to receive $1,500 for every 6 months for the next 20 years. So that's a little different, isn't it? Right? So what she's doing, she's guaranteed an interest rate of 6.25% compounded semi-annually. That's 2 per year. How much must Mary deposit now to pay the annuity? So this is an interesting type of scenario where she doesn't want to have a regular monthly income. So obviously Mary has something else going on. Maybe she has a little side business, or maybe she has other income, right? Some people get company pensions, right? Maybe government pension, something like that. But she wants to get $1,500 every 6 months for the next 20 years. What does that mean? Well, maybe she wants to give her grandkids some money for school every 6 months for the next 20 years, right? Maybe she wants to be able to buy her, her grandkids a something nice, maybe a car, maybe maybe she wants to buy him a snowmobile or something. What I'm saying is that there's something, or maybe she wants to take a trip every 6 months. Yeah, that's probably what she's doing. The point is that you don't have to get it just as a regular monthly thing or a bi-weekly thing. You can get it once a year. You can get it twice a year, as she's doing, and for 20 years. It's an investment that you're buying. Okay, so it's like if you get a loan from the bank, right, then they know that you're going to pay them a certain amount of money every month or every other week, right, for a certain period of time. So she's doing the opposite. She's lending the bank some money, and they're going to pay her. All right, well, let's try this one then. Now, this is page, just want to make sure I'm on the right page here. Okay. Okay. All right. So this should be on page 26. And there's just 2 support questions for the RSP. So I'm going to make a new page here. Okay, so this is page 26, and this is support question number 6. All right, and so what we want to find out is the PV of this thing, right? That's what we really want. They call it, when it's an annuity, they call it the A. So let's just scratch that out and call it the A, but we know what it is. Okay, that is how much does she have to pay for it now? Okay. So, and then she wants her R to be 1,500, regular payment to be 1,500. The interest rate is going to be 0.0625. Now let's watch this here because it's compounded semi-annually, twice per year. And now our N is going to be twice per year times, she wants it for 20 years. See, now notice they said every 6 months, right? So if it's possible to look at that and say, oh, well, it's 6, right? 6 times 20 or 6, right? But it's every 6 months. That's twice per year. We have to think about this first number as the number of compounding periods per year. Number of compounding periods per year. Okay, so that's why I sort of go through these in a step-by-step way. It's just that, so that we can catch these little things where they kind of try and trick us in the question. I don't know if they're trying to trick us, but that would be a common way to say that. Well, now, do we have everything we need to solve this problem? I think we probably have everything we need. Okay. So, well, we need the formula. So the formula, and this is this is the PV version of the annuity formula. Okay. So A equals R times 1 plus I to the positive n minus 1. Remember, we're going to give you all these formulas, so don't get too worked up about it having to memorize them. You have to know which one to use, but the annuities formulas will say A, right, and the PV formula will say PV. Okay, so I think we're good. So let's try this. So she wants $1,500, and it's 1 plus 0.0625 over 2 to the power 40 minus 1. This seems like it's going to be a little easier to calculate, over I, which is 0.0625 over 2. Okay. Now, you know that my method is to take that 2 and just kind of do it like that, right? And it's just mathematically you're allowed to do that. So, but I'm gonna solve this stuff on the inside first. So, grab my calculator here. All right, so 0.0625 divided by 2, got it, plus 1, got it, to the power 40. Got to be careful because it's a positive here. Minus 1, got that, times 1,500 times 2. Okay, so, and I get 7272.58434, just to show you, and 0.0625. I already took care of the 2. So now I'm going to divide that number by 0.0625, and I get 36135. Okay, so she would have to put 116,361.35 into that annuity, which makes sense. That's about how much we're expecting her to put in there, right? Now, if we weren't sure, we'd always look it up at the back. Let's look it up at the back here. This is page 26. So right at the back of Unit 2, support question answers for Lesson 9. And we're looking at support question 6. And so, let's see. Oh, okay, I'm getting, okay, I got all the numbers are the same except that I used a different formula. 1 minus. Okay. I don't know, I'm a little, it's quite a different answer, isn't it? Oh, all right, let's go take a look here. A, annuity formula. Oh, whoops. Yeah, I did use the wrong formula. Sorry about that. All right, well, let's fix it. Let's see what happens when, so the formula I want to use is on page, yeah, the formula I want to use is on page 24. No, I did use the right. Oh, that's contribution. Sorry. Yeah, I made a mistake. So what I have to do is just reorganize this. That 116 looked correct, so go figure, right? Let's see. So it's going to be the this PV formula. Oh, present value of annuity. Okay, so I gotta change this to use the PV formula. Sorry about that. Let's try it again. Now, so, in this case, I really can't just change some numbers because it wasn't just a little glitch on the numbers. Okay, it's the whole formula I used was wrong. So I could have crossed it out and just moved on here. So it's the PV is what I'm looking for. R. So, when I say to look and see if your answer makes sense, very often we can tell if it makes sense, but sometimes it's just not possible. All right, there we are. The answer, the mistake, sort of looks reasonable, right? But once you do a few of these questions and you start getting more familiar with the numbers they use and the answers that you get out, then maybe you'll be able to detect something, even if it's just off by, say, in my case, I think it was like 5 times too big or something like that. It didn't really sort of set off any alarm bells. All right, well, let's try again. 1500, 1 minus, all right, 1 plus I, which is 0.0625. The good news is that really it wasn't the numbers, it was the formula, right? So the numbers were all correct. 0.0625 over 2, okay? And okay, so I'm going to crank that through my calculator again and try it. So 0.0625 divided by 2 plus 1. Okay, and so now we are taking it to the negative 40. All right, and then 1 minus, and I have a sort of a way of, okay, times 1500 times 2, and then divided by 0.0625. And indeed, I got the same answer as they showed at the back of the book, which is 33. Actually, it was out by about an order of 3. And yeah, and those kinds of mistakes are kind of hard to detect. It's just a matter of having a little experience with the types of numbers you're working with. That's, let me try this again here. Having some trouble with that. No. Okay, let's try it again. That's better. Well, that wasn't what I wanted to do. I have my problems today. Okay, try. I don't get that. I'm trying to erase. I'm having some real problems with the eraser. Wow. I don't even know. I'll just leave it. That's a 9. Anyway, I'll change colors. There we go. It's a 9. So 33,982. So that's how much she would have to put into the annuity. That seems low to me, but I don't know. I guess that's because it's a fairly high interest rate. I would think that she would have to put a little more in. So I've just shown you why the picking the right formula is kind of an art, and it really is. And that's really all the practice you do in this unit will be to pick the right formula, because by now I think getting everything on the left-hand side should be pretty straightforward, right? It's a matter of picking the right formula and then cranking through the calculations. Okay. All right, well, let's take a look at the next support question. Okay. And see what we can do with that one. All right, so Josh is 27 years old and wants to start, so this is on page 26. So Josh is 27 years old and wants to start putting money into an RRSP, okay, on a bi-weekly basis, so that's 26 per year, right? Okay, there you go. And if he wants to have $1 million by his 65th birthday, how much should he deposit regularly if he can earn an average interest rate of 6.75% compounded bi-weekly? Does this seem reasonable to justify your answer? Okay, so basically Josh wants to be able to put $1 million away, 27 years old, starting a little later, but might not be so bad, right? So what formula are we going to pick here? Okay. And that's, we sort of need to answer that one. Right. Okay, so I'm pretty sure that it's going to be the annuity formula. Okay. Let's see. Oh, okay. Well, it's the same one, right? So yeah, so it looks to me like you're going to use the regular payment version of the one that we just looked at. Okay. So instead of the A version of it, it's the R version. Okay, because our A the value of our annuity, this is going to be our A right here, right? And so what we want to know is what is the R. I think we have everything else. Okay, so I'm going to start a new page. I think, yeah, we got time for this. So this is page 24. Page 24, support question number, is it 7? Please, 7. Okay, yeah. Okay, so our A then is going to be $1 million. One with 6 zeros. Our okay, and our R, our R is the thing we don't know. Our interest rate is 0.0675. And now this is the thing, and biweekly, which is 26 per year. Our N is, now here's the thing, we need to know, he's 27 now. We need to know how many years it is, right? It's bi-weekly, so it's 26 per year times, it's 65 minus 27 is what it is. We have to work out how many years it's going to be. He wants to, when he's 65, he's 27 now. It's 38 years, so it's 26. Let's try that again. So it's 26 per year times 38 years. Okay, times 26, 988 bi-weekly payments. That's actually pretty good, isn't it? Okay. And I think we got everything we need. So now I'm gonna use the formula, and so it's gonna be R equals, so it's our A times I, and then on the bottom it's 1 plus I to the power N, yeah, minus 1. All right, and I'm gonna change to blue. Looks like we got time to finish this. So this is going to tell us what he has to save every other week for the next 38 years in order to have his $1 million. Okay, so his A is going to be $1 million. Now you can write this any way you want, and then the I is going to be 0.0675 over 26, and then in the denominator, oops, I actually left out a bracket there. In the denominator, it's going to be 1 plus 0.0675 over 26 to the positive n. Yeah, the positive n. So that's going to be 988 minus 1. Okay, so now that we have all that done, and assuming, presuming I picked the right formula, this should all work out. Now, when you're multiplying a whole number by a fraction, you can multiply straight across and then divide. So we have 1 million. Okay, it's 1 and 6 zeros. Double check that you just have 6 zeros, not 5 and not 7, times 0.0675 times, what did I just say? Times 0.0675. I don't know what I actually said, but that's what I meant to. Okay, and I just pressed the wrong button. All right, 1 million times 0.0675 equals. Okay, and then divided by 26, and we have a number for the numerator. It's 596.153,846, and we're going to try not to. We're going to try and keep that in the calculator as much as possible. Now, for the denominator, we got to go through the same thing. It's basically 0.0675 divided by 26 plus 1 to the power 988 minus 1. And so we have that, which is 11.95751,831. And we'll just divide those two out. 2596. I wasn't able to keep that one in my calculator. I guess I should probably work it out. Okay. And just rounding it off. So this is $217.11. So basically the answer then, he needs $217.11 biweekly. So, that's not an outrageous amount of money, is it? I mean, it's a lot of money, you know, but it's not an outrageous amount of money. Let's say that he was looking at it buying a new truck. Okay, we looked at that the other day. Maybe the new truck is $800 a month, which would be something like $400 biweekly, right? So let's say that, what's his name, Kevin? Josh. So let's say that Josh decided that instead of buying a new truck, okay, let's say that he's going to buy a used truck, okay, and he's able to get it for $200 biweekly. Well, now he's within striking distance of being able to put the other $200 biweekly into his RSP to reach his goal, right? He just needs another $17, okay? So let's say he decides not to eat at, at the restaurant every day, and so he saves himself $5 a day, and now suddenly he's able to do it. But he suffers for that, right? He doesn't drive a new truck, right? Maybe he doesn't, instead, maybe he drives a new truck, but he doesn't go on vacation. Maybe he doesn't buy an ATV when he'd really like one. He borrows his uncle's. The point is that it's doable. It's a lot of money, but it is doable if that's what he chooses to do. But he's got he's got 38 years, to pursue that dream of having $1 million when he gets to be 65. Okay. Not easy, but it's certainly doable. And if he knows the number he needs straight away, then that's right. Then that's a help. Now, the other thing I would say about this is that when you're 27, maybe $217 is tough, right? But when you're 37, when you're 47, then you're making a little more money, right? And maybe it's a little easier. So maybe when he's young, he can put 150 in there, and then he just keeps adding to it as he gets a raise or something like that, right? All right, well, let's go back and take a look. I think we got both of those done. And so then question 9, key question 9 would be all the key questions. There are not that many this time around. Whoops. I think is there only 4 here? Just double check. Oh no, okay, there's 6 of them. But, in the first unit, we did lots and lots of these questions. In this case, we're just really going to do a little sampler. Okay, so look at those key questions. Give them a try. I suggest that you send them in. Don't just try and do a whole unit's worth of key questions. Send in the key questions so I can mark them and get them back to you and get some feedback. Okay. All right, well, let's wrap it up today. We'll come back for lesson 10, the first half, tomorrow. And thanks for joining us.